All right, so our next set of notes for this chapter are proving that two functions are inverses. And to do that, there are two steps. So the first step is showing that f of f inverse equals x. And then the second step is showing that f inverse of f of x equals x. This looks super confusing, but if we substitute the inverses with the f and the g, what that means is we're using composite functions. So if you take the g of x function and substitute it in the f of x function and simplify it all the way down, and we want it to equal x. And then you do it the other way. So then you put the f of x function into the g of x function and simplify it down as far as you can, and we want it to equal x. The only way that they are functions is if both options simplify to x. Okay, so when you simplify, they both have to equal x. So let's go to our first example. So here we're trying to determine whether f of x and g of x are inverse functions. So f of x is x squared plus 8, and g of x equals the square root of x minus 8. Okay, so the first step is f of g of x. Oops. So f of g of x. So that means we're putting the g function in for x here. So we have the square root of x minus 8 squared plus 8. Okay, so now we're going to simplify this as much as we can. So we have the square root squared. So when that happens, they cancel each other. So this part simplifies down to x minus 8. And then we still have the plus 8 over here. And then we can combine like terms. So negative 8 and positive 8 are 0. So essentially they go away. So we're left with just x. So far, this first set matches because f of g of x simplified to just x. But now we have to do it the other way. So we have to do g of f of x. So now that means we're putting the f of x function in for x and g of x. So we have x squared plus 8 minus 8, but all of that, is underneath, is underneath the square root sign. Okay. Now simplify everything we can underneath of here first. So positive 8 minus 8, 0, so that goes away. So we're left with the square root of x squared. And as we've already said, if you take the square root of a square, they cancel. So we're left with just x. So both of these simplified to just x, which means f of x and g of x are inverses. Ooh, that all kind of blurred together. All right, so they are inverses. They both simplify to x. So let's go to our next example. So we have f of x equals negative 4x plus 5. G of x equals x over 4 minus 5. So let's start with f of g of x. So we're going to put the g of x function into f of x. So we have negative 4 times x over 4 minus 5 plus 5. So we're going to distribute the negative 4. So we have negative 4x over 4 plus 20 plus 5. So this will simplify. So negative 4 over 4 is negative 1. So we have negative 1x, and then 20 plus 5 is 25. So we have plus 25. So right away, this one does not simplify to x. So there's no way they can be inverses, but we're going to do the other one just for practice. So we have g of f of x. So that means we're putting the f function into g. So we have negative 4x plus 5 over 4 minus 5. And at this point, there is no way to simplify any of this. So right away, we can say that f of x and g of x are not inverses. Okay, so in this situation, neither one simplified to x, so right away they're not inverses. All right, so now we have f of x equals the square root of x plus 4 plus 9, and then g of x equals x minus 9 squared minus 4. So let's start with f of g of x. I don't know why I keep ending that too soon. So we're putting g into f of x. Okay. So we have x minus 9 squared minus 4 plus 4, and all of that is still underneath the square root, and then this plus 9 is outside. So start simplifying under here what we can. So we have minus 4 and positive 4, so those are going to go away. So we have x minus 9 squared, still underneath the square root sign, plus 9. And then we have the square root of a squared, so remember those cancel. So we're left with x minus 9 plus 9, and then negative 9 and positive 9 cancel, and we're left with just x. So far, all of this simplified to x, but now we also have to check g of f of x. So now we're putting f into g. So we have x plus 4 underneath the square root, plus 9, minus 9, and all of that squared, minus 4. So start inside the parentheses. So the positive 9 and the negative 9 are going to cancel. So we have the square root of x plus 4 squared minus 4. So we're squaring a square root, which means it goes away. And we're left with x plus 4 minus 4. So the positive 4 and the negative 4 go away, and we're left with just x. So once again, both versions simplified to just x. So that means f of x and g of x are inverses. And I think that is our last example.